Welcome to Lesson 8 of our Distance Learning series. Today, we're going to talk about the results from our tug-of-war simulation. You'll need a pencil, today's journal slip, your journal slip from yesterday with your data, and your science journal. I want you to look at your data tables from yesterday. Do you see some patterns across these data? What are some rules that you can use to make predictions about which way the cart will move? Remember, we conducted these trials to see if we could figure out how forces could cause motion. So we're going to answer some questions to get your thinking going. Does it matter that the people are red or blue? Was color an important variable in our investigation? Think about mass as a variable. How is that important? Does a large person always win each competition? If two people pull on each side, does the cart always stay still? What about where the person holds the rope? Is that variable important when thinking about forces in motion? And how does the sum of the forces help you understand which way the cart will move? Pause this screencast now and really take time to put your thoughts on paper. The more you push yourself to think, the more deeply you will understand the concept of forces and how they can cause motion. Let's see how you did. When talking about forces in motion, it doesn't seem to matter which color the competitors are. When I did some trials, I had the red team win some of the time, and in other trials, the blue team won. That really didn't matter. In fact, a large person didn't always result in a win. Here, you can see that I made this big blue competitor tug against two smaller competitors. And guess what? Neither side won. The cart didn't move at all. But the cart didn't always stay still. Sometimes I made one side win over the other. Like here, the blue side won. This is because the blue competitor pulled with more force than the red competitor. So the cart started moving in the direction the blue competitor was pulling. And it didn't seem to matter where the competitor held the rope. Here I have two equal-sized competitors. One, the blue, is pulling the rope closer to the cart than the other, the red. But the cart didn't move. It didn't matter where the competitors pulled from. The cart stayed still. The biggest factor that made the cart move was the amount of force each side exerted on the rope. Here, the blue side, it pulled with 250 newtons of force, while the red side pulled with only 50 newtons. This meant that the blue side was pulling with 200 more newtons than the other, and so the cart moved in the direction of the pull. I hear another force rule coming up. I know. I get so excited when we figure out something new. So one of the things we can say is if the sum of the forces is 0, then there's no movement. We say the forces are balanced. This means the forces are equal and opposite in direction, so there's no movement. But if the sum of the forces is greater than 0, we say that the forces are unbalanced and motion will occur in the direction of the larger force. Think about that the next time you go to push a heavy object and it doesn't move. Or, better yet, think about forces when you see a scene like this. Here's the flash. Let's watch.
Okay, this is definitely east.
Slowpoke?
Oh, it's on.
I'll take the ones on the right.
It's okay.
Hey, watch right here.
Hold on.
Okay, so does the Flash have superhuman strength? Or was he just exerting more force against the car than the car exerted on him? And so the car moved in the direction that he was pushing with greater force. See? Science can explain so many things. Today, submit your completed journal slip. And maybe watch your favorite superhero movie. Spot some more examples of forces at work. Until tomorrow, keep thinking and keep learning.